In this video, we'll look at how to find a cubic's zeros using synthetic division. Well, our cubic is x cubed minus 8x squared minus 3x plus 90 equals 0. Solving this will find the zeros. But first, before we can use synthetic division, we need something that actually works. And we use a thing called factor theorem. That is a factor, a zero, that's actually going to work for this equation. What I mean is, we got to sub something in here. This is how factor theorem works. That actually makes this equation equal 0. And the only way we have to do that is guess and check. We got to try some x value and see if it's working. So I write try x equals 1. That's going to be my first try. Always try small integers. I would suggest 1, 2, 3 or negative 1, 2, 3. Let's try x equals 1. When you sub x equals 1 in here, I get 1 cubed minus 8 times 1 squared minus 3 times 1 plus 90. Notice I don't put equals 0 because I don't know yet. I don't know what it's going to equal. I'm trying to make it equal 0. I'm guessing at x equals 1, but I don't know. I'm going to solve it here. 1 cubed is, of course, just 1. 1 times 1 times 1. And here you have take away 8 times 1 squared. 1 squared is 1, so that's minus 8. And then I have minus 3 times, but this was a terrible choice, right? Hopefully you can see, right away 1 wouldn't have worked. It wasn't a great choice to try. So I can stop and just say, that's not equal to 0. This is not going to be one that works for me. I need a different choice, something that's going to work. I take a look and see, is 2 going to work? I wonder if 2 subs in. But I just quickly do some math in my head. It's going to be like 8. This is 2 squared is negative 32. It doesn't look like 2 is going to pull off much of a victory there. So I'm going to try 3. My next choice is going to be try x equals 3. Sometimes you have to go through a few trial and errors to get one that works. What's 3 cubed minus 8 times 3 squared minus 3 times 3 plus 90 equals 0? Whoa, not equal 0. I don't know yet. I can't put equal 0. I don't know what it's going to equal. The last one wasn't equal 0, so I can't put it. Okay, this is 27 minus, and what's 3 squared? I could do that on my calculator, but I can try in my head. 3 squared is 9. 9 times 8 is 72. Minus another 9 plus 90. That I don't want to chance it. I'm going to do on the calculator. 27 minus 72 minus 9 plus 90. I get 0? Nah, 36. But I liked some of the math in here. You have to guess and check, but I'm going to make an educated guess. 2 was too small. This 3 didn't quite work, but I liked the numbers kind of came close. I wonder if negative 3 would work, because if I put negative 3 in here, I'd get more negatives maybe. This would have, I wonder if that's going to work. Yeah, this number here would still be negative. Let's see, so I'll show you what I mean. My educated guess, my intuition says try x equals negative 3. So I'd get negative 3 to the power of 3 minus 8 times negative 3 minus 3 times negative 3 plus 90. And what do I get when I do that? Well, this is negative 27. This is plus 24 now. Oh, I forgot the squared here. That doesn't make sense. Can't be plus 24, because it would have been 24 there last time. So let's see what we get now. This is 9. Oh, it's still minus 72, because this is negative 3 squared, and negative squared is a plus. So negative 3 squared is positive 9, times negative 8 is negative 72. Minus 3 times minus 3 is plus 9, plus 90. I think that might be it. My intuition, I think, served me well. Negative 27 minus 72 plus 9 plus 90. I get 0. Alright, I've got one that worked. When you show your work, you have to at least show the one that worked. If you make a bunch of guesses, you don't have time to write them all, that's okay. But at least show the one that works. You have to show this work. When we do synthetic division, we use this number that we got. This is a 0. We're trying it. That's actually a 0 that works. If you watch the video on long division, with long division you use the factor. We would have used x plus 3. So little note to self, synthetic division uses the 0 you subbed in. Okay, let's set up this box here. This is how synthetic division works. You set up a box and you put the coefficients of the polynomial you're looking at. Coefficient of x cubed here is just a 1. There's no number there, it means it's a 1. Next coefficient is negative 8. Next coefficient is negative 3. And the last number, the constant, is 90. Outside here is my 0. Okay, step 1, bring this number down. This first coefficient comes down, a 1 goes here. Next step is going to be multiply. Negative 3 times 1. You get negative 3. Now you're going to take this column and add. What's negative 8 plus negative 3? Negative 11. It's always the same two steps now. It's going to be multiply and add. You're going to take negative 3 times negative 11, multiply. You get positive 33. Now you add. Negative 3 and 33 gives you 30 when you add them. Let's check that again. Just see how it's working. Multiply to get this. Then add to get this. Same thing one more time. I'm going to take this negative 3, multiply by the last number down here. Negative 3 times 30 is negative 90. Now add. You get 0. And you better get 0 here, because this column is your remainder. Alright, rem, just so you know, that's a remainder. And so there better be a remainder of 0, because we found it's supposed to be 0. The factor theorem tells us it goes in. This number here is your constant. These are your x's, and these are your x squared. So we now have started to factor it. We've broken this down into x plus 3. Remember I said this was the 0? So its factor is the opposite sign, x plus 3. What makes this bracket 0? Negative 3. So the factor is x plus 3. And we're left with this stuff here, an x squared minus 11x plus 30. Okay, that all equals 0. But we have to break this down some more. We need to break down this quadratic. We'll use Bergman technique. You could watch the video on Bergman technique. But what it basically says is you want to find two numbers that multiply to this constant and add to this x coefficient. So what multiplies to 30 and adds to negative 11? Well, I need 5 and 6, I think. 5 and 6 multiply to 30, but they add to positive 11. So I need negative 5 and negative 6. Negative 5 times negative 6 multiplies to 30. Negatives cancel out, but they add to negative 11. I'm good. So now I have this, x plus 3, and I broke this quadratic down into two pieces, an x minus 5 and an x minus 6. Lots of students stop here. We're not quite done. We're not asked just to factor. If it just said factor, you're done. This is factored form, we're done. But we're not done a question, find a cubic zeros. To find the zeros, we set each of these pieces equal to 0. If the equation equals 0, then either x plus 3 equals 0, or x minus 5 equals 0, or x minus 6 equals 0. Any one of those could be true. I'm going to box this up to make sure it doesn't touch my work. It's separate. So how do you get rid of plus 3? Subtract 3 both sides. One of my zeros is negative 3. Put a box around it. That's all you have to do. No final answer, just one of my zeros, negative 3. How do you get rid of negative 5? You add 5 both sides. Another one of my zeros. There's 5. I've got negative 3 as an answer, 5 as an answer. How do you get rid of negative 6? Plus 6 both sides. And you get x equals 6. And we did it. We used synthetic division to find a cubic zeros. First we had to guess and check till we found a 0 that worked. We used that 0 to do synthetic division with this box. We write down our new factored polynomial where this last digit is a remainder. Remember that. That should be nothing or you've done something wrong. And then we use what we've got left, this quadratic, we factor it, we get 3 terms in our factored form, and we solve each one. Those are our zeros.